back to my channel. So in this class we'll discuss the class 12 series, and in the previous class we discussed what is relation and what is range and domain, and in this class we will discuss types of relation. So the types of relation, there is different kind of relation. So first there is reflexive relation. So reflexive relation, symmetric, transitive and equivalence relation, and then we will discuss example related to equivalence relation. Clear? So next, what is reflexive relation? So reflexive relation is that a relation R on a set A is reflexive if for every element in A, every element such that A in A set A, that is the order pair A comma A belongs to R. Clear? So means there is a set, and for every element of A there should be a order pair A comma A, and if there is element B, then there should be a order pair B comma B, and similarly C comma C. Then we can say the relation is reflexive. Okay. Now symmetric relation. What is symmetric relation? A relation is said to be a symmetric relation if order pair A comma B belongs to R, then there should be a order pair B comma A must be belongs to R. Means if let us consider a set A 1, 2, 3, and R be a relation in set A, then given by R, the relation R is like that 1, 2, for that it should be 2, 1. Similarly, if it is 1, 3, it should be 3, 1 one of the ordered pair. Next, we will discuss transitive relation. So, what is transitive relation? A relation is said to be transitive relation for all A, B, C in A. If A comma B belongs to R and B comma C belongs to R, then A comma C belongs to R. Means if the element order pair A comma B belongs to R and B comma C belongs to R, then the first element A and the last element C means A comma C belongs to R, must be belongs to R. And R is, for example, R is said to be transitive relation. So I consider our relation R1 such that P comma Q such that P parallel to Q. So if I draw P and Q, this is P and Q line segment, and R2 another relation Q comma R such that Q parallel to R, means there is another line segment R parallel to Q. Then we can say this P line and this R line is parallel. Obviously P and R is parallel to each other. So means P comma R, this ordered pair belongs to R. So in this case we can say this is transitive relation. Clear? Now we will discuss equivalence relation. What is equivalence relation? A relation is said to be equivalence relation if it is symmetry, reflexive and transitive relation. So these three conditions is satisfied, then it is said to be equivalence relation. So let us consider a set A 1, 2, 3, and the relation is defined like that. Then we have to check is it equivalence or not. So first we have to check reflexive relation. So if 1, 1, 2, 2, 3, 3 is if every pair for every element there should be a reflective pair 2, 2, 3, 3. That is why we can say this is reflexive relation. Next, symmetric relation 1, 2. So there should be 2, 1. Yes, 1, 3. There should be 3, 3. 2, 3. There should be 3, 2. Yes, they are present in the relation. That is why the relation is R is symmetric here. Next, transitive 1, 2 and 2, 3. So means there should be 1, 3 belongs to R. Yes, this is here. Similarly, so means here reflexive, symmetric and transitive relation, both three of them condition is satisfied. That's why R is said to be equivalence relation here. Now we will discuss some question of equivalence relation. So if consider A is a set and R is defined like that, we have to check it the R is reflexive or not. So reflexive means for every pair 2, 2, for every element we have to check the order pair is exist or not. 2, 2, 3, 3 and 4, 4, 5, 5. These four order pair should be belongs to R. Then we can say this is reflexive. Yes, they are present here. 3, 3, 4, 4, 2, 2. Yes, so R is reflexive. R is a reflexive relation. Clear? Next, symmetric relation means if there is 2, 1, so there should be 1, 2. if there is 1 comma 3, there should be 3 comma 1. So yes, so 3 comma 5, here it is 5 comma 3. So means R is also symmetric. R is also symmetric. Yeah. Now we'll discuss transitive. So transitive means here, so you have to check if 5 comma 3. So you should 5 comma 3 means this should be 3 comma 5. Yes, 3 comma 5. 3 comma 5 is there. And for that pair, it should be a relation 5 comma 5. First and third. This one and this one belongs to R. Yes, 5 comma 5 belongs to R. That's why R is also transitive, means R is an equivalence relation. Equivalence relation. Clear? Next question. Let T be the set of all triangle in a plane with R reflection in T is given by R T1 comma T2 such that T1 is congruent to T2 so that R is an equivalence relation. Yes. So means T1 and T2 are triangle and the condition is given T1 is congruent to T2. For reflexive means T1 comma T2. So there should be ordered pair. So T1 comma T1, also T2 comma T2. Yeah, that is satisfied because T1 is congruent. So the triangle itself is also congruent. T2 is a congruent triangle. So T2 also congruent. So means here R is a reflexive relation. R is reflexive and symmetric relation. So means T1 comma T2 it belongs to R. So T2 comma T1 also belongs to R. Yes, obviously if T1 is congruent to T2, so T2 also congruent to T2. So that means this is also R is symmetric also. R is symmetric. Now transitive. So what is transitive? So if I write T1 comma T2 belongs to R and T2 comma T3 belongs to R. So there should be a relation order pair T1 comma T3 belongs to R. Obviously if T1 congruent to T2 and T2 congruent to T3, so there should be, so it should be T1 congruent to T3, means R is transitive. R is transitive. So these three conditions satisfy reflexive, symmetric and transitive. So R is an equivalence relation. Here, next question. So L be the set of all lines in a plane and R be the relation in L defined as R equals to L1 L2 such that L1 is perpendicular to L2 so that R is an equivalence relation. So means L1 and L2 two lines, it is defined like that L1 is perpendicular to L2. So if I draw L1 is a line, L1, this is L1 line, and L2 another line. So obviously L1 and L2, L1 and L1 cannot be perpendicular to L1. L1 cannot be, so L1 comma L1 does not belong to R. Similarly, L2 comma L2 does not belong to R also, because L2 cannot be perpendicular to L2. That is, it is not reflexive. R is not reflexive. Clear? Now symmetric. Symmetric means L1 comma L2 belongs to R. So it is that clear? L2 comma L1 belongs to R. Obviously, if L1 is perpendicular to L2, so L2 also perpendicular to, this is 90 degree. So it is 90 degree forming. So belongs to R, means R is symmetric. Clear? Now transitive. So means L1 comma L2 belongs to R and L2 comma L3 belongs to R. So these two pairs belongs to R. So there should be another pair L1 comma L3 belongs to R. But let us check here. Suppose L1 is a line. This is L1 perpendicular to L2, and L2 is a perpendicular to L3. Means there should be another line L3. But this should be perpendicular. No, L1 and L2 cannot be perpendicular, so means L1 L3 does not belong to R, so means R is not transitive. Since R is not reflexive, R is not transitive, but it is symmetric, so R is not equivalence relation. So you have to show R is not equivalence relation, because R is not reflexive and R is not transitive. That's why R is not an equivalence relation. Next, show that relation R is the set of integers given by R belongs to P comma Q, that such that 2 divides P comma Q. So if I say P comma Q is divisible by 2, we can say also. So means P comma Q means if I satisfy P comma P equal to 0, 0 also divisible by 2, divisible by 2. Again, Q minus Q equals to 0. So means it is divisible by 2 also. Divisible by 2 also means P comma P belongs to Z and belongs to R, relation R, and Q comma Q belongs to R also. That means it is reflexive. Okay. Now symmetric. Symmetric means if P minus Q is divisible by 2, then it should be Q minus P also divisible by 2. Means if I change this value, minus P minus Q divisible by 2 also, yes, minus of P minus Q, that means P comma Q belongs to R and Q comma P also belongs to R. That is, it is symmetric also. Clear? Means it is integer. So means if suppose result of P minus Q is 4, it is divisible by 2, and if it is minus 4, it is also divisible by 4. We can consider negative number because they are integer. Integer can be negative. That's why. Next, transitive. Transitive means if P minus Q belongs to R and Q minus R belongs to R. That means if P minus Q minus, if I write Q minus R, it implies that P minus R. So means P minus, yes, if the result is P minus Q is 4, suppose 4, and Q minus R is suppose 8, because it is should be divided by 2, and the result of this also divided by 2, and 4 minus 8 will be minus 8, it should be divided by 4. Means P minus R is divisible by 2. That means P comma R belongs to R. That is, transitive relation also hold here. So that means R is an equivalence relation satisfied. Clear? So I hope you understand this some example that is belongs to NCERT example. We discuss for your understanding better. Next video we will discuss NCERT exercise 1.1, and we will discuss question number 1. From this will be 1 to 5 we will discuss. Okay, so thank you for watching this video. If there is any doubt, you can comment in the comment section, and if you like this video, you can like, share and subscribe also for getting the notification. So thank you. Tata.